Hello there. We start off with the fourth and the final class of the chapter Permutation and Combination. And in this class, we are going to discuss the topic of combination. Now, to begin with, some of you, if you have already done it, then you must be knowing that combination means selection. We are just selecting few objects. So here the arrangement is not important. So we are just going to pick few objects from a given set of objects, and the number of ways we can do so, that is called combination. So to begin with, if I am selecting R objects from n distinct objects, now mind you, we are talking about distinct objects. Now if there are not distinct objects, there are objects which are alike, then we can definitely follow the same way which we have done in case of permutation, and we can do it. So we are not having a separate video, or I am not giving you a separate formula on how to solve questions on combination having alike things, which will be part of the problem itself. We are going to do such problems, so we will see how we are going to deal with them. So let us begin. So if I'm selecting R number of objects from n distinct objects, then that is given by n factorial by r factorial into n minus r factorial. Now this is denoted by so many different ways. You can write C within bracket n comma r, or within first bracket n and r, or NCR, which is the most common notation. So this is called combination. So combination of R objects selected from n objects. Now along with this comes few properties. So let us just run through our eyes on those properties, and if you want the proof, you can check on the book, or you can just prove it all by yourself. They are very simple proofs. Just follow the definition and work on it. You will get the answer. So the first one is NPR is equals to R factorial into NCR, which is very obvious. If you just follow the definition of NPR is basically n factorial by n minus R factorial. So NCR, the formula is right on your screen. If you just multiply R factorial to it, you can see the R factorial and R factorial both in the numerator and denominator gets cancelled, and so you get NPR. Next, NC0 is equals to NCN, that is equals to 1. Again, put the value of 0 or n in place of R and calculate, you will get the answer. Then NCR is equals to NCN minus R. Very evident, in place of R, if you put n minus R, you will see you get back the same thing. So therefore NCR is equals to NCN minus R. Then the fourth one, NCR plus NCR minus 1 is equals to n plus 1 CR. Now this property has got no practical application directly, but this is something that happens, so we can just remember it. Next, fifth one, which is having a lot of practical application, and it is one of the fastest way to calculate permutation. If you want to calculate mentally without using calculator, and it is very important that you do not use calculator always, because using calculator actually retards your solving time. I mean, it just increases the solving time. So therefore it is very important that you can do your calculation mentally. So NCR can be written as n into n minus 1 into n minus 2 dot 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 up till n minus r plus 1 by r factorial. So whenever we are doing problem, we will see how we can make use of this particular formula, the last one, to solve problems. So now let us move to examples directly, so we don't have much more to talk about. 35c n plus 7 is equals to 35c 4n minus 2. Now I have to find the values of n. Now why there are values? Because let me just explain it. See here, now there can be two different ways I can solve it. Remember, n c x equals to NCY, this can lead to two things. Either x can become equals to y, that is one possibility. Obviously, if in the both the x and y are equal, then ncx and ncy, these two values will become equal, obviously. Or we also studied that ncr, I mean ncr is equal to nc n minus r. So that means this r plus this n minus r, that makes it n. So therefore x plus y can also be equals to n. So there are two different results that we have. We can have either x equals to y, or we can have x plus y equals to n. So following these two criteria, what do we get? We get this 35cn plus 7 equals to 35c4n minus 2. From this I get either n plus 7 plus 4n minus 2, that is equals to 35, or n plus 7 equals to 4n minus 2. So from there, if I solve, I get values of n as 6 or 3. So there are two different values of n. NC10 is equals to NC12, find NC3. So same way, you can see NC10 is given equals to NC12. So therefore, what is n? N is equals to 10 plus 12, that is 22. And so similarly, if you are trying to find 22C3, just see how I have done this. I have exactly made use of the formula. So 22C3, that is NCR, is equals to 22 into 21 into 20, that is n into n minus 1 into n minus 2 up till n minus r plus 1. So how to understand or how to remember this in short? Remember this number, it is 3. So therefore, remember, from starting from this number, I am going to go 3 steps backward, or rather 2 steps backward, because there is n minus r plus 1. So going 2 steps backward, take all the numbers, multiply them and divide by the factorial. So therefore it is 22 into 21 into 20 by 3 factorial. That's it. So this calculation you can do mentally as well. You need not require any calculator to solve. Fine. Now let us move to number 3. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 courses are compulsory for every student? Now, as you can see, 2 courses are compulsory, so those 2 courses have to be there, and you have to choose rest of the 3 courses from 7 courses. So therefore, you can do it in 7C 3 ways, and that is 7 into 6 into 5 by 3 factorial, and that is 35 different ways. Right? Let's move on. Number 4. What is number of ways of selecting 4 cards from a pack of 52 cards, which include exactly 1 red queen? Now, this is the first card question which we are going to solve, and there will be several other card questions. Now, let me just give you the whole idea of cards. Now, card questions, I don't know if you have done it in your junior classes, if you remember. Now, there are, in a deck of card, there will be 52 cards, and there will be 3 different colors. One is called club. Then the next one we have is, please don't mind my drawing, this is called spade. Then let me change the color a bit. Then we have the diamonds. And finally, we have the hearts. Obviously, I didn't write them in the exact order. It should be club, diamond, heart, and spade, but nevertheless. Now, each of these cards are, let me change the color once again. Let me go to a different color now. So there are 13 each of these cards, 13 each of these cards. Each of them, these are called the suits. These are called the suits. Now, each of these suits having 13 cards each, and each of these cards are numbered starting from 2 to 10. These are numbered cards. And then there are cards which are picture cards. Picture cards means they have, or face cards as they are called. They are printed, something is printed on them, some faces are printed. They are basically Jack, the Queen, and the King, and finally Ace. Now, Ace is definitely not a face card because there is no face printed on it, but it is also not considered as a numbered card because it is not a number. So Ace is an absolutely separate card. These cards are called face cards, and from 10 to A, that is 10, J, Q, K, and A, they are called as the honors card. HONOURS, honors card. Why honors card? Honors in the sense that these cards have got some extra high values in different games of card. Now, obviously, there are several different games of card. In different games, each of these cards have got different values, but in most of the games, these cards starting from 10, J, Q, K, and A, these cards are called honors card. Now, this honors word is basically used when there is a game of bridge, when you are playing a game of BRIDGE, bridge. In this game, this word honors is used. In different other games, this word may not be used, but there was a question last year where students had doubt that which one is called the honors card. So starting from 10 till A, these cards are called honors card. Fine, so that's the trivia about your cards. If you know, it's very good. If you don't, so you just learned it now. Now let us go back to the question. So the question says, what is the number of ways of selecting 4 cards from a pack of 52 cards which include exactly one red queen? Now, how many red queen are there? Obviously, there are 2 red suits. So from those 2 red suits, I will get 2 red queens. So there are only 2 red queens. So how many ways I can select any one of the red queen? I can do it in 2 ways. Obviously, there are 2 from which I am selecting one. So 2C1, that is 2 ways. Now, there are rest 50 cards from which I must select other 3 cards because I am actually selecting 4 cards. And it is asking that one of them must be a red queen. So of those 2 red queens, I must select one. And then from rest of the 50 cards, I must select rest of the 3 cards. So therefore, that I can do it in 50C3. Now calculate 50C3, that is this number 19600. So therefore, in total, how many ways we can select all these 4 cards? That is 2 into 1. I am sorry, I forgot to change this number. Please, I always have some or the other mistakes. So this is 19600. Please get that right. So that is 39200. Right? Okay, let us move to the next question. Number 5. Now, this question is very important for the next chapter that which we are going to do, that is the chapter of binomial theorem. But it is good that we learn how to solve the question here so that it becomes a routine work to solve the very same question when we do the chapter of binomial theorem. Now, it is a question given that n-1 CR is to NCR is to n plus 1 CR equals to 6 is to 9 is to 13. So I have to find the value of n and r. So let us see how we do it. So this is the question given. Now let us write all the formula as it is given. So n minus 1 CR, let us write what it is. NCR, let us write what it is. So same for n plus 1 CR. Now you can see there's a room full of things written. So let me just explain one by one. So the first case, I have just written what all these individual formulas are. Now you can see there are so many common things which we can cancel out. So I have cancelled out. All the r factorial in the denominators get cancelled. So I have cancelled out. Then n minus 1 factorial can be cancelled from all the three numerators. So if you cancel out n minus 1 factorial from the numerator, you will be left with 1 in the numerator in the first place. In the second place, you will be left with only n. In the third place, you will be left with n into n plus 1. And then in the denominator, you can see n minus r minus 1. That can be cancelled. The whole factorial can be cancelled. So in the first case, you will be left with only 1. In the second case, you will be left with n minus r. And in the third case, you will be left with n minus r plus 1 into n minus r. Fine. So now this is just routine factorial calculation. I think you are not going to have any problem understanding. Now let us move to the next step. So all I need to do is, now you know how to solve ratios. You take 2 at a time and solve. And then once you take 2 at a time and solve, obviously there are 2 unknown variables. You will get 2 different equations in 2 unknown variables. Solve them and you will get the answer. So let us do that. So if I take the first two, that is 1 is to n by n minus r, that is equals to 6 is to 9, I get first a relation between n and r, that is n equals to 3r. So mark this as number 1, leave it. Let us move to the second one, that is the second set of ratios, that is n by n minus r is to n into n plus 1 by n minus r plus 1 into n minus r. So now again you see there are common factors, they get cancelled and then you get the equation. So I am not explaining how these equations are coming, just try it, solve it all by yourself once, you will get it. Now here the value of n, you can use 3r because that was the relation you got in the first equation. Put it here, solve it, you get the value of r as 4. So therefore from there you get the value of n as 12. Right? So this is a very good question. So you are basically solving ratio problems at the end of the day, but with a small hint of factorial and combination involved. Okay, let us move to question number 6. Question number 6. A box contains 5 different red and 6 different white balls. In how many ways can 6 balls be selected so that there are at least 2 balls of each color? So therefore what it means, I have to select 2 balls of each color. I mean 2 red and 2 white ball has to be there. Then the other 2 balls can be any ball, that is either it can be red or white, 1 red, 1 white, both red, both white. So there are 3 different cases that we have. So let us take those 3 cases and calculate. So the first case, I have 2 red and 4 white balls. So if I'm taking 2 red balls, I can select them in how many ways? 5C 2 ways. 4 white balls can be selected in 6C 4 ways. Now therefore by rule of multiplication, you multiply them, you get 150. Then 3 red and 3 white balls, 5C 3 into 6C 3, that is 200. And finally 4 red and 2 white balls, that is 5C 4 into 6C 2, that is 75 different ways. Now if you add them up, you get 425 different ways you can select all these balls. Fine. Now let us move to number 7. Number 7. How many words with or without meaning, each of 2 vowels and 3 consonants, can be formed from the letters of the word honesty? Now first we need to find out how many vowels and how many consonants it has. Now I can see there are two vowels only, O and E, and rest of them are consonants. So there are 5 consonants and 2 vowels. Now, how many vowels and consonants do I need to form the words? I need 2 vowels and 3 consonants. So 2 vowels selected from 2 vowels. How many ways I can do it? 2C 2 ways, that is only one way because both of them have to be taken. And then I have to select 3 consonants out of 5. So that I can do it in 5C 3 ways, that is 10 ways. So therefore, these are the selections that have been made. Now, all these letters, they can arrange themselves in different ways. Why? Because you are forming words. Now, whenever I am forming words, the permutation matters because the arrangement of letters give you different words. So therefore, all these 5 letters can permute within themselves in 5 factorial ways or 5p5 ways, whichever way you want to call it. And that is 120. So therefore, the total number of ways of forming 5-letter words out of the letters of the word honesty is this. All these things will be multiplied. So 1 into 10 into 120, that gives you 1200 ways. So you can make 1200 different words out of the 2 vowels and 3 consonants of the letter honesty. Now, last question, like this question is exactly what I was talking about, that this will give you the idea how to work with combination if there are repetitions or there are objects which are alike. So you can see the word combination. This word itself has got so many letters repeated. So you are having exactly the situation which we took in our previous class, where we had like objects, similar kinds of objects. So we are going to see how we can do it. Now let us read the question first. How many 4-letter words can be formed from the letters of the word combination? So here I am not taking the whole word at once. We are taking 4 letters only. So that makes the whole situation a little bit different. Now you could have asked this question, that why this question is not in the exercise or under the topic of permutation, why this is under the topic of combination. Now I will give you the answer very shortly, and the answer will be the solution itself. Now here you see, as the question is asking how many 4-letter words out of the letters of the word combination. So at some point of time I have to select the letters, right? I have to select which letter I want to make the word. So there is a concept of selection coming in the solution. So therefore there will be some combination involved, and that is the reason why this is a question which involves combination. So therefore we couldn't have solved this question if this question would have been given in the exercise of permutation, because we would have had half knowledge to solve the problem. So let us see how we can solve it. Now there are certain things we need to understand. Whenever I am taking these 4 letters, there can arise 3 set of cases. What are the 3 cases? See, if I have these 4 letters taken, now in these 4 letters, what may happen, all the 4 letters may be different because there are so many letters out there. So all the 4 letters may be different. So this can be X, Y, Z, T, any 4 different letters it can be. Or it may happen that that 2 of the letters may be same and the other 2 letters may be different. That can be another case. Or it may so happen that 2 letters are of one kind and the other 2 letters are of another kind. There can be these 3 different cases, because in the word combination there are such cases possible, because all the 4 can be different, 2 same, 2 different, or there are 2 pairs of similar letters. Fine. So let us take all these 3 different cases and let us see what are the number of ways in individual cases. The first one, all the 4 letters are distinct. If all the 4 letters are distinct, then how many ways I can make 4-letter words? See, How many distinct letters are there? First of all, if you just see, there are 8 distinct letters. C, O, M, B, I, N, A, and T. So there are 8 distinct letters. So out of these 8 distinct letters, if I select 4 letters, so I can make 8C4. So I have selected out 4 letters out of 8 letters, and all these 4 letters can permute within themselves in 4 factorial ways. So basically you are actually doing 8p4 only. If you just look closer, you are actually doing 8p4, but as we are doing combination, I have just written it in terms of combination. Now you could have said that, so this is pretty much permutation only. Not yet. Let us move to the second case and let us see what happens there. In the second case, let us go back to the second case. Now in the second case, what we are doing, we are taking 2 similar letters and 2 similar letters and 2 distinct letters. Now in this case, what happens, you see, how many pairs of similar letters are there? I can see there are 2 O's, I can see there are 2 I's, and I can see there are 2 N's, right? There are 3 different pairs of similar letters, right? Now of these 3 pair of similar letters, I need to choose one, right? So how many ways I can choose it? 3C1 ways. So that is this one. Now once I have chosen any one of this pair, then how many distinct letters are left? Obviously, in total there were 8 distinct letters. I have already chosen a pair of similar letters, so I will be left with 7 distinct letters. I will be left with 7 distinct letters. So of those 7 distinct letters, I have to select 2. So therefore 7C2, right? Now let us go back to the same thing. Now this 4 factorial is basically all those 4 letters can permute within themselves in 4 factorial ways, right? And now of which I already have a pair of similar letters, so I need to divide it by 2 factorial. Clear? So therefore that is the second case, and this is what you get. So now if you are saying that this is pretty much the same as permutation, the answer is no, not the same as permutation. Why? Because this 4 factorial has to be shown separately, because this 4 factorial comes here also and it will come in the next case as well. So if you would have written 8p4, it is fine, but that wouldn't have helped you understand the whole question properly. And if you have a very clear brain, you are welcome to write it that way, no problem. Now let us move to case 3. Case 3, in this case, I will take 2 pairs of similar letter. So if I take 2 pairs of similar letter, so there are 3 pairs of similar letters of which I am selecting 2, so that I can do it in 3C2 ways. And then all those 4 letters can arrange within themselves in 4 factorial ways. But as there are 2 pairs of similar letters, so I have to divide by their repetition. So that is 2 factorial into 2 factorial, right? So that gives you this particular value. And so finally, what is the total number of 4-letter words that we can form? I need to add them up. So if I add them up, I get this. So this is the number of 4-letter words that I can form, right? So the question seems pretty easy, but it is not. There is a lot to it in this question. So go through this type of question. They can come for 4 marks or 6 marks at best. So that's it. That is the end of the chapter. And as always, if you have any doubt, get it cleared. Thank you.